All right, these are the answers to the quiz review, first couple pages. So we want critical numbers. When are we decreasing, increasing, relative min, relative max? So we're going to go ahead and take the derivative, which is 12x cubed minus 12x squared minus 240x. We're going to set that equal to 0. I'm going to go ahead and pull a 12x out of everybody. Give us x squared minus x minus 20. So that gives us x minus 5x plus 4. So our critical numbers are going to be -4, 0, and 5 based on that. Okay. Then we're going to go ahead and test those out. So I'm going to put a line here, -4, 0, 5. We're going to test the first derivative. So if I put some large negative number into this first derivative, I'm going to get a very large negative number here. And so therefore I'm going to get a negative on that. That means our function is decreasing there. If I pick something between -4 and 0, maybe -1, I put it in, I'm going to get -12, but then I'm going to get +12 and then positive 240. That gives me a positive value there. So we're increasing. If I pick, say, +1 and put it in, I'm going to get 12 minus 240. That's a negative value there. Then if I pick a large positive, say 10, and put it in, I'm going to get a large positive minus this, but it'll still be a positive value. All right. So when are we decreasing? We're decreasing when the derivative is negative. That's from -infinity to -4, and from 0 to 5. When are we increasing? When the derivative is positive, from -4 to 0, from 5 to infinity. Okay. When do I have a relative max? When my derivative switches from positive to negative, that's at x equals 0. When do I have a relative minimum? When the derivative switches from negative to positive, that's at -4 and at 5. Okay. So that was pretty straightforward. Same process for all the rest of them. Here our derivative is 5x to the 4th minus 20 times 3, so it'll be 20x squared. So when I set this equal to 0, I'm going to pull that x squared out. I'm going to get, and I'm going to pull a 5 out as well. That's going to leave me with x squared minus 4 left over. So that becomes 5x squared times x plus 2x minus 2. So our critical numbers here would be -2, 0, and 2. Right, so we're going to test those out on our number line here, -2, 0, 2. If I pick some large negative number, put it into the derivative, I'm going to get a positive. So some large positive and then a negative, but it won't be negative enough. So this is going to be positive here, which means our function is increasing. If I try like -1 in there, I'm going to get 5 minus 20. That's a negative. So that's decreasing. If I try +1, I'm going to get the exact same value. So that's negative, decreasing. If I try a large positive number in here, I'm going to get a positive minus this. This is going to be positive. Okay. So when are we decreasing? We're decreasing from -2 to 0, 0 to 2. You can put it as two separate things. There isn't a discontinuity there, so technically you can do it -2 to 2, or like I said, you can split it if you want to be safe. Either of those are fine. As far as increasing goes, -infinity to -2, 2 to infinity, that would be our increasing. We're going to have a relative max when our derivative switches from positive to negative. That's at x equal -2. We're going to have a relative min when our derivative switches from negative to positive. That's at x equal 2. Right. So again, kind of a straightforward one, but with that x squared, it created a critical point that ended up not being a relative anything. For number 3, now we have a little bit more work to do here. Our derivative is going to be a quotient rule. It's going to be x minus 1 times the derivative, which is 2x plus 3, minus x squared plus 3x plus 5 times the derivative of the bottom, which is 1, all over the bottom squared. Okay. So if we FOIL this out, on top we're going to get 2x squared. 3x minus 2x is 1x. -1 times 3 is a -3. If I put those together now, my derivative will be 2x squared minus x squared, which is x squared, x minus 3x, which is a -2x, -3 minus 5, which is a -8. Now we know that x equal 1 is an asymptote. That's from the very beginning. So 1 is going to be a critical number for us for sure, because that's where the derivative is undefined. But Up top, you can see that that factors into x minus 4, x plus 2. So that creates critical points at 4 and negative 2 as well. So our critical points, negative 2, 1, and 4. 1 is an asymptote. We have to keep that in mind. We still have to kind of use it to differentiate between increasing and decreasing. But it's not going to be a relative minimum or maximum because of the asymptote nature to it. All right. So now we can go ahead and test all these out. Negative 2, 1, and 4. If I pick something that's smaller than negative 2, say negative 10, I'm going to get 100 plus 20 minus 8. That's a positive, and the bottom's always positive because of the squaring on the bottom. So this is going to be a positive derivative, which means our function is increasing. If I put something between there, in there, if I say put 0 in, I'm going to get a negative over a positive. That's a negative. Our function, our derivative is negative. Our function is decreasing. If I pick something between 1 and 4, say 2, put it in, I get 4 minus 8. That's a negative, decreasing there. And then if I put something bigger than 4, I get a large positive to start with. So we're increasing. So we are decreasing from negative 2 to 1 and from 1 to 4. And we do have to split that one because of the discontinuity at 1. You can't say from negative 2 to 4 because we're not continuous all the way through there. Increasing from negative infinity to negative 2 and from 4 to positive infinity. Okay. So where would we have a relative maximum? That's where our derivative switches from positive to negative, and that's at x equal negative 2. Where do we have a relative minimum? That's where the derivative switches from negative to positive. That's at x equal 4. Okay. Then for our last one, we're going to set up our derivative, which will be 1/2, and then the derivative cosine is negative sine. And so when I set that equal to 0, I'm going to get 0 equal to 1/2 minus sine x. If I add that sine x over, it's just sine x equal to 1/2. So really I'm looking at when does sine equal 1/2. So if I kind of think through, the opposite, adjacent, hypotenuse, sine 1/2 would be opposite over adjacent, or opposite over hypotenuse. And that's for 30 degrees, or pi over 6. So I know that pi over 6 is a critical number. But then sine is positive in the second quadrant too, so if I go to the second quadrant with that same reference angle, I'm going to get 5 pi over 6. Okay. So those are our critical numbers. So now as far as testing it out, I'm going to go pi over 6, 5 pi over 6. Pick things that are easy to work with. We're talking about putting them into this derivative here, right? So if you pick 0, the sine of 0 is 0. We'll get 1/2 minus 0, which is 1/2. That's a positive. Our function is increasing. In between pi over 6 and 5 pi over 6 is 3 pi over 6, which is pi over 2. The sine of pi over 2 is 1. 1/2 minus 1 is a negative. So our function is decreasing. And then if you pick, say, pi, which is bigger than 5 pi over 6, sine of pi is 0. We're going to get a positive there. Our function is increasing. So our function was decreasing from pi over 6 to 5 pi over 6, increasing from 0 to pi over 6, and 5 pi over 6 to pi. All right. Where do we have a relative max? We have a relative max when the derivative switches from positive to negative, and that's at pi over 6. We have a relative min when it switches from negative to positive. That's at 5 pi over 6. And I see that it says 2 pi, so I really should make that 2 pi right there. All right. So that's how we do the first derivative test on those 4.